Hello everyone, happy to see you here. Welcome back to my channel, Hi Mathematics. Today we have a very interesting, quick, I would say like a relaxing algebra question. We know that the product a times b equal to 1 and a sum a plus b equal to 1, and we need to find our a and b. If you have your answer, your assumption, you can also write your solution down into the comment section and then we will check your answers. Okay, so if you look closely, this is the basic algebra system of equation. And first of all, we can easily express from the second equation, let's express our b. So b equal to 1 minus a. Let's do this right now. So b is equal to 1 minus a. And right now, instead of b or in the first equation, let's plug in 1 minus I. Let's do this. As a result, what do we have? We have a times, instead of b, we're going to plug in this, 1 minus a. So we have 1 minus a equal to 1. Right now, if you look closely, we have only one variable. We have only our a, so we can easily find this a. First of all, let's multiply this a by these parentheses. As a result, what do we have? We have a minus a square equal to 1. Right now, if you look closely, this is our quadratic equation. Okay, so let's change an order a little bit. Let's write this one on the left side. So let's do this. So we have a minus a square and minus 1 is equal to 0. Right now, let's change an order because we prefer this second power on the first position. So let's do this. So we have minus a square plus a and minus 1 is equal to 0. And the final step, like for solving this quadratic equation, is to multiply or divide both sides by minus 1. Because when we multiply or divide, we can easily change this sign in the beginning. We prefer quadratic equation with the positive sign in the beginning. So we have a square minus a and plus 1 is equal to 0. So right now we have a basic quadratic equation. So after all the steps, we have a basic quadratic equation, and of course we can easily solve it without any problems with the coefficients method or your own method. How can you solve it? Okay, I'm going to show you with the basic all-known method, a equal to 1, method of coefficients. So we have b equal to minus 1, and c is equal to 1. First of all, I'm going to find real quick discriminant, and then I'm going to plug in this discriminant into our formulas. So we have d equal to, we have b square minus 4ac equal to b square. We have minus 1 square minus 4 times a times c, 4 times 1, and times c equal to 1. And right now, what do we have? We have 1 minus 1 square. We have 1 minus 4. So as a result, our discriminant is negative. So right now, let's plug in this discriminant in all known formulas. So we have a first and second is equal to, we have minus b plus minus square root of discriminant and all over to a. This is our all-known formula. Let's plug in each of these elements into this spot. As a result, what do we have? Minus b minus minus 1 plus minus square root of d plus square root of discriminant is equal to square root of minus 3, and we divide it by 2 times a times 1. Right now, minus 1 equal to 1 plus minus. This square root of minus 3 we can easily write as square root of minus 1 times 3. So we can easily split it like square root of minus 1 times 3. And right now, according to a basic square root property, so when you have a product of two values, of course, with the square root sign, we can easily split like square root of minus 1 and square root of 3. So equal to 1 plus minus square root of minus 1 times square root of 3, and we divide it by 2. Right now, square root of minus 1, this is our imaginary unit. This is our I. So we have 1 plus minus I square root of 3 over 2. And the final move, we can easily split it by real part and imaginary part. We can divide it by 2. So as a result, we have 1/2 plus minus I square root of 3 over 2. And these are our two roots to our question. So these are our a first, a second, and of course we need to find our b. First of all, I'm going to write a first with the positive sign. So a first equal to, let's write it with the positive sign. So 1/2 plus I square root of 3 over 2. And of course, a second, let's write with the negative sign, equal to 1/2 minus I square root of 3 over 2. Right now, don't forget about our substitution. Not like substitution, we expressed our b equal to 1 minus a, okay? b equal to 1 minus a. So b equal to 1 minus a. So right now let's find our b first and b second. So b first is equal to 1 minus a first, 1 minus a first. And as a result, we have b first equal to 1 minus a first equal to 1/2, plus I square root of 3 over 2. Of course, we can easily open up parentheses. We have b first equal to 1 minus 1/2 minus I square root of 3 over 2, and 1 minus 1/2 equal to 1/2. So our b first is equal to 1/2 minus I square root of 3 over 2, and we have one pair of roots. Okay, we have a first and we have b first, and right now let's find our b second. Okay, so b second is equal to 1 minus a second. Okay, as a result, we have b second is equal to 1 minus 1/2 minus I square root of 3 over 2. Right now we'll open up parentheses, so we have b second equal to 1 minus 1/2 and plus I square root of 3 over 2. 1 minus 1/2 equal to 1/2. So we have 1/2 plus I square root of 3 over 2. So it looks like mirrored solution. Yeah, we have right here plus minus, and right here we have minus minus plus. Okay, so we have two pairs of root. Let's write our final answer to this question, and then we will check real quick our roots. Okay, so we have our answer. The first pair, we have a first, so we have 1/2 plus I square root of 3 over 2, and we have the second 1/2 minus I square root of 3 over 2. These are our first parentheses, and of course we have the second one. We have a 1/2 minus I square root of 3 over 2, and the second we have 1/2 with the positive sign, 1/2 plus I square root of 3 over 2. So we have two pairs of root, and right now let's check it real quick. In the beginning we had our question, so we had ab equal to 1 and a plus b equal to 1 as well. Right now let's check it real quick. We have right here multiplication and addition. First of all, let's check our addition real quick. We don't need to check both of these cases because we have addition. So 2 plus 3 equal to 3 plus 2, so we can easily like change an order, because doesn't matter, you have 2 apples and then 3, so as a result you have 5, or you had in the beginning 3, you get 2 more, so as a result you have the same 5. So we can easily we can't check both of these pairs because we have absolutely the same result. So let's check, for example, this one. So we check in addition. So 1/2 plus I square root of 3 over 2 plus 1/2 minus I square root of 3 over 2 need to be equal to 1. Let's see what will happen. First of all, we can easily cancel this and this one, and as a result we have 1/2 plus 1/2 equal to 1. So addition works great. Addition works absolutely perfectly. Right now let's check real quick our multiplication. So multiplication, we have two parentheses, we multiplying a times b, and absolutely the same principle. We don't need to check both of these because it doesn't matter. 2 times 3, 3 times 2, we have 6, so it doesn't matter what pair we're gonna choose, this one or this one. I'm gonna choose this one, for example. 1/2 plus I square root of 3 over 2, we're gonna multiply it by 1/2 minus I square root of 3 over 2. And if you look closely, it looks like these are a school identity. Yeah, we have right here the same expression, so 1/2, 1/2. This one is absolutely the same with this one, so we have a plus b, a minus b. And if you know a little bit about math, these are a school identity, a square minus b square. This is equal to a plus b times a minus b. So we can consider it as a difference of two squares. So this to the second power, so we have 1/2 square minus b square, but b square equal to I square root of 3 over 2. So we have I square root of 3 over 2. And we're gonna raise this also to the second power equal to 1. And right now 1/2 to the second power equal to 1/4 minus, right here we're gonna raise to the second power each of these elements. So we have I square, so I square root of 3 to the second power. Okay, let's write it. So square root of 3 to the second power, and we're gonna divide it by 2. And if you look closely, I squared, this are a minus 1, so as a result we have 1/4 plus, of course we have minus 1, with this minus we have plus, square root of 3 to the second power equal to 3, and we divide it by, right here we have 2 square, we're going to divide it by 4. So 1/4 plus 3/4, of course, this is equal to 1. So our roots are absolutely great, and you can see right here our multiplication works absolutely perfectly. So I don't have enough space right here, so this is our answer. You can easily see this answer right here at this place. So we have two pairs of of roots. We have the first parentheses, we have a and a b, and right here a second and b second. You can easily see a proof, you can easily see this proof, you can easily see this check. And of course, I really hope you understand this explanation. I really hope you learn something new. To be honest, this is not a hard question. This is a question from basic school algebra, but maybe a lot of students interested in this type of question. Of course, I have a lot of question on my YouTube channel, and I really appreciate that you watch my videos. And thank you for your time. Have a great day. Also write your notes, write your response down into the comment section. It will be really interesting to read what you think about this type of question. And of course, thank you for your time. Wish you all the best in life. Take care of yourself, and I definitely wish you all the best in your mathematical adventure. And see you in the next videos. Have a great day and take care of yourself.